Ish.
Ish? Ish. Can I have your attention for 1 sec, everybody? 1 minute, please. Could you stop? As I'm going around to the tables, I'm noticing that some people are not 100% clear on what I'm asking them to do. So I would like Pascal, Tiffany, and Adam, could you please, sorry, Tammy, could you please come to the blackboard, put your thing up with the magnets, and let's just see one example so everybody can be on the right track. Okay? Just take 2 minutes. Okay, no magnet are there. Okay, so right on the blackboard, you considered it S plus 2, right?
Yeah.
S plus 2 equals, and then how many times, you talk about it, how many times you're going to do that, okay? All right, guys, just stop what you're doing for a second and watch what they're doing. This will help you, so stop what you're doing. Nicole and Caroline, you got to stop and watch. Okay.
Pascal said that you should leave the sides as holes since like there's each side equals S and you have to add the corners twice, so one side will equal S plus 2.
Okay, let's stop right there. Do you see how one side is S plus 2? What, can I just come in for a sec, guys? We're calling this length S. It doesn't matter if it's 4, if it's 10, whatever, it's S. Okay, where's the plus 2 that they got? Shayna? The 2 corners. So they're saying that this whole thing is S plus 2. How many times do they have to count the S plus 2 in order to get the whole border?
Chloe.
4 times.
So that's why we put it in brackets and times it by 4.
Now, do you think that's finished? What did you guys come up with next?
When we were putting these on the side length, when you count them, you'll count them twice, and you wouldn't want to put. How would you say this? You wouldn't want to double them and make it thick. So when you count them twice, you'll count them twice 4 times. So what you would do is you would do times 4 minus 4.
Who can explain why they subtracted 4 out at the end?
Because by doing that, you'd basically be finding the perimeter of the pool with the tiles, but you're just finding the number of tiles, so you can't have 4 extra sides that you'd be getting, so you have to subtract them.
Anybody want to add on to that? Claire, why do you think they subtracted 4?
I'm not sure, actually. Because they multiplied by 4, then they subtracted 4. I don't really understand that.
Why did they multiply by 4? Tiffany?
I guess because S plus 2 is one side and they have to do all sides. And
Uh-huh.
there's 4 sides, so they have to multiply the whole equation by 4.
Do you see that, Claire? 4 sides, so each side is S plus 2. But now, why are they saying they have to subtract that 4?
Because they get too much.
Why would they get too much?
Because they would find out more than they needed to know.
Why?
I'm not sure.
Who can help her? Why are they getting too much? Amber?
But they will find the perimeter of each tile plus the outside of the pool, and they didn't want that. Like Lulu said, they don't want that. They just wanted the side plus the 2 corners times each side length of the pool.
Okay, so there's a difference between perimeter and the number of tiles. When we did the launch, the perimeter was greater. Why was the perimeter greater? Tiffany?
Because we counted each side of the corner.
Each side of the corner tile, how many times?
Twice.
Good. When you're doing perimeter, you end up counting each side of the corner tile only twice. So if we do this formula just like this, times 4, we're actually finding the perimeter, we're counting each corner tile twice. Do we want to count each corner tile twice? So how do we make up, how do we compensate for the fact that we counted each corner tile twice? what do we have to do? What do we have to put on the equation to make sure the number of tiles will be correct? To readjust it. Subtract 4. So then you'll only be counting each one of the corner tiles once. Or if you counted it twice, you're taking 4 out. Do you get it? Okay, think about this. This is the kind of thing I'm asking you to do. There's so many other ways to do this. See if you can come up with some other ways in the next 5 minutes or so, and then we're going to come back for a share, okay? Okay, who wants to go first? Lulu, can you go second? Okay, who wants to go first? Siri, which one's yours?
The blue and big one.
The blue and pink one?
Yeah.
All right, why don't you come up and explain this?
Okay.
Tammy, come on. Natalie, you need to move over so Tammy can get in.
Okay. So, well, first of all, we started out kind of like, we didn't really understand what we were doing. But then, Miss Allison came over, and so she moved the tiles around to like, she took this away, and she said, like, how can you figure out an equation with like this, okay? And so we figured that, wait, what was it?
That if you take this, since this is like one side, because you have 3 of the side length plus corner tile on each side. So we said that if you multiply that by 4, you would get
Yeah.
the amount of tiles.
And so then, first we wrote it without the brackets, and then Miss Alta said, then if you think order of operations, it says multiplication first, and that's what we don't want, because we want to figure this out and then multiply it for, so then we put in the brackets. And then if you just take away that and you show it 4 times, that's what that looks like.
Because it's, well, this says S1 plus 1 times 4. Same thing as saying add this 4 times. So that's what we did. S1 plus 1, S1 plus 1, S1 plus 1, and S1 plus 1. And S1 plus 1 means that you have it means that you have one side length, and then plus 1 of these, which is 4 more. Do you understand? Okay. You have one side length, which is 3 of these, plus 1 of the corner tiles. So it's like,
Why don't you group it?
it's like taking this. Okay.
That's one of their chunks.
So you take this, that. That's 4. So so you take S1, one side length, plus 1 of these, 4 times. Okay.
That you have to multiply one whole side plus the corner 4 times for each side length of the square.
Okay, and then our other equation was, okay, so we figured that, okay, side length equals 3, right? So 3 times, because, 3, 4 times, right? So then we just figured that, then that is 4.
Okay, you have the side lengths equal to 3. You have 4 of those side lengths. So we put that in as 4 side lengths. So then you have
So it's 12. So then 3, 4 times is 12.
3 times
Then
4 is 12.
we had to add the 4 extra ones. So then, since we're trying to figure out the number of tiles, not the perimeter, because at first we thought it was 8, which was the perimeter, and then she said we're trying to figure out the number of tiles. So then we just put 4, so it's 12. No, yeah.
We're not going to talk about that right now because we're running out of time. But Lulu, I would like you to come and explain your group's strategy.
Okay. So should I write the equation on the board? Or?
Sure.
Okay. The equation that our group got was n equals S plus 2 minus S squared. And that would find the number of tiles because S plus 2. Hold on. S plus 2 squared. Okay. N equals S plus 2 squared minus S squared. Because when you figure out the area of the whole thing, you would be finding length times width, or side squared, because this is a square. And S plus 2 would give you a side, because the side is S, or 3 in this case, plus 2, which is the corners. And so, using this as an example, when you do S plus 2, you get 5. So 5 times 5, or 5 squared, would give you 25, which is the area of the whole thing, like the pool with the tiles. And then when you subtract side squared, which gives you the area of the pool, you get 9. And so then when you subtract 9 from 25, you get 16, which is the number of tiles that you need.
Wow, what do you think of that? Who gets it? Who doesn't really get it? Without saying any specific numbers, can you just tell me the big idea? What did you do? What was your method?
You find the area of the pool with the tiles and subtract the area of the pool to find out the number of tiles that you need.
Does this remind you? Okay, so can somebody else then say what Lulu did? What did Lulu's group figure out? How did they do it? It's a subtraction method. Area of the outside. Not 100% sure, huh? Natalie, want to give it a shot?
I didn't really look at it as, I didn't see how they found it by using the subtraction method, but I got how they found the equation. S plus 2 would be the side plus the 2 corners, and then squared because that would be length times width. And since it's a square, it doesn't matter what you multiply, or like which is the length and which is the width, because both are the same. So S plus 2 times S plus 2 is the same thing as S plus 2 squared. And then you would subtract S squared, which is 5, just
Don't put the number in.
right,
Just subtract S squared.
so that you wouldn't have one extra side.
So you see, which part don't you understand, Natalie?
No, I'm still trying to make sense of how they use the subtraction method to find the equation.
Okay. Lulu, you want to try one more time?
Well, okay. You'd be using the subtraction method because the perimeter of the pool with the tiles is like a big square.
The area.
The area of the pool with the tiles is a bigger square than the square inside. And you'd be finding the area, I guess, of the tiles around it, which
Natalie-
would be
Sorry,
the
go ahead.
number of tiles that you have.
Natalie, when you were telling me the area of the whole thing when we were first together in a group, you said that you added 2 things together, right?
Yeah.
What did you add?
S plus 2.
What?
S plus 2.
When we were doing the launch at the beginning.
Oh, I was adding the outer area. I was adding the number of tiles that made up the border plus
Yes.
the area of the inner square.
Okay, so you were adding up the number of tiles in the border plus the area of the inner square. So you said this plus this is going to give me the area of the total. Now take it apart. What's Lulu starting out with?
S plus 2 squared.
So she's starting out with the area of the border, the area of the pool, or the area of the whole thing?
The area of the whole thing.
The area of the whole entire thing. And so she's starting with all of this. What is she subtracting out?
The area
Of
the
what are you subtracting out, Lulu? The area of the pool. She's starting with the area of the whole thing, subtracting out the area of the pool, and what is she left with?
the area of the border.
The area of the border. Okay, we'll come back to this because I know not everybody is 100% sure on this. But Lulu's equation is written right up here. Now look at all these different equations. We have 1, 2, 3, 4, 5 different ones. How do we know if those are all the same?